This video will be dealing with absolute value. In order to understand absolute value, it's important to understand the definition of absolute value. Absolute value is the distance from zero. That's all it is. It's just a way of indicating how far a value is from zero. So if we were to ask what is the absolute value of 3, what we're really asking for is how far from zero is the number 3. And looking at a number 9, we can see that 3 is 1, 2, 3 units from 0. So the absolute value, the distance from 0, of 3 is 3. Seems simple enough. If we were to look at the opposite direction, say -3, and ask the question, what is the absolute value of -3? It doesn't matter that we're now asking about a negative number. We're still looking for the distance from 0. And looking at the number line, we can again see that -3 is 1, 2, 3 units from 0. So the absolute value, the distance from 0, of -3 is also 3. Because all we're doing is distance. Distance is always positive. You never have a negative distance. You never say you went -3 miles. You might say you went 3 miles in this direction or 3 miles in that direction, but you don't have a negative distance. We don't deal in negative distance. So since absolute value is distance from 0 and distance is always positive, therefore absolute value is always positive. A lot of people look at a situation like this where they have the absolute value of -3 is +3, and they think that absolute value means opposite. But that is not true. The absolute value symbol is just asking for the distance from 0, and whether you're talking about -3 or +3, the distance from 0 is always going to be 3. For either -3 or +3. All we're talking about is distance. We don't care about which direction we went. All we care about is how far we went. That kind of makes absolute value the odometer of mathematics, you might say. Your car doesn't pay attention to what direction you travel. All it pays attention to is how far you've traveled. So if you got in on Interstate 8 in Yuma and you started driving and you weren't paying attention, you're kind of in a fog, and you notice, oh crap, I've gone 60 miles, but I don't know where I am. Your car can't help you. You look down at the odometer, all it says is 60 miles. You don't know which direction you've gone. You could be 60 miles east in Dateland or 60 miles west in El Centro. The car doesn't care. The car can't tell you. You have to look around and find other information. 60 miles is 60 miles, regardless of which direction you go. +60 and -60 would both have the same absolute value of 60, because they're both 60 miles from 0. Now for a little geography lesson, Arizona, Dateland is to the right on the number line, so that's positive. El Centro in California is to the left on the number line. That's negative. So we have just mathematically proven that Arizona is a positive thing and California is a negative thing. It's not me, it's just the numbers. Can't help it. Now all that is when we know what value we're trying to find the absolute value of. That's arithmetic, when you go from the problem and find the answer. But in algebra, we know the answer, and we're trying to find the problem. Take, for instance, the equation absolute value of absolute value of x equals 5. We know the answer is 5. What we're trying to find out is what is the problem. What's the question? So we need to determine what values of x will give us an absolute value of 5. So if the obvious answer might be, well, the absolute value of 5 is 5. And that is correct. But the absolute value of -5 is 5 as well. When we're solving an absolute value equation, we need to account for the possibility that x can be either positive 5 or negative 5. We've said that the absolute value has to be positive. Absolute value, and I'm just going to abbreviate here, absolute value is positive. And that is true. Absolute value is always positive. But the value inside the absolute value sign can be either positive or negative. There's no restrictions on that. And when we're solving an algebraic equation, the value inside the absolute value sign is what we're trying to find. So we have to account for the possibility it could be positive or negative. One way students find helpful in remembering that is when they look at the absolute value sign of these two vertical bars. One bar reminds them to have a positive value, and one bar reminds them to have a negative value. X could be either 7 or negative 7. So that's how we write our answer. Simple enough. Sometimes there's more to the value inside the absolute value sign than just an x. In this case, absolute value of the quantity x plus 2 equals 10. It really doesn't change much. We still want to account for a positive 10 and a negative 10, because both could exist inside the absolute value sign. All we need to do is write what is actually in the absolute value sign down in front of the equal sign. Notice we don't change anything from inside the absolute value sign. X plus 2 is x plus 2 is x plus 2. That doesn't change. What we're changing is what is it equal to. It could be equal to a positive 10 or it could be equal to a negative 10. Once we have these two equations that we're reminded of by the two bars in the absolute value sign, then we can simply solve the two equations. And we get x equals negative 12 or 8. Cool. There could be something outside the absolute value sign. If we had this equation, the absolute value of x is minus 5 equals 6, we don't want to deal with the absolute value just yet. And there's a mathematical reason for that. You may recognize these letters as referring to the order of operations. The order of operations, when I was a kid, we remembered it as PEMDAS. Nowadays, people use the phrase, "Please excuse my dear Aunt Sally." Either way, it's to remind us that we first do things in parentheses, then we do things that have exponents, then we do anything being multiplied or divided, then we do anything added or subtracted. But that's what we do for arithmetic when we know the problem and we're trying to find the answer. But in algebra, we know the answer and we're trying to find the problem. So we need to go backwards on the order of operations. It's just like over the river and through the woods, to grandmother's house we go. But when we've been there for a while and we're tired of the old people smell and we want to get back to our computers, we need to go home by reversing our route and going through the woods and over the river. Same thing in math. So in algebra, we need to do whatever's added or subtracted first, which would be 5. Then we can do the absolute value, because the absolute value is on the order of operations way up there. It's a form of parentheses. Instead of curved parentheses, they're straight parentheses. But they serve the same function, similar function at least as far as order of operations is concerned. So first, we get rid of that 5. Then we do order of operations. We split it up into the two equations equaling both the negative and the positive value. It doesn't matter which one you do first, positive or negative. Some people like to do positive first, some people like to do negative first. If you do negative first, then when you write your answer, it'll be in that order, because we generally will put the negative before the positive in our answers. And some people just like to have things orderly like that. The same is true if something is being multiplied or divided instead of added or subtracted. Going backwards on the order of operations, we need to deal with the multiplication before we deal with the parentheses. And so that means we have to get rid of the 2 first. And we end up with the absolute value equals 4 and x equals negative 4 or positive 4. If we put it all together, if this was our problem, 5 times the quantity of x plus 3 divided by 2 plus 7 equals 17. Going backwards on the order of operations, we have to first get rid of the 7. Then we have to deal with the multiplication and division. It doesn't matter which order we do them in. I generally take care of the division first, then the multiplication. And now I can finally deal with the absolute value and solve these two tiny little itty-bitty equations for a solution of x equals negative 7 over 1. And we can check it by putting those numbers back into the equation. If x was negative 7, we'd have negative 7 plus 3 is negative 4. Absolute value of negative 4 is positive 4. 4 times 5 is 20. 20 divided by 2 is 10. 10 plus 7 is 17. If we used 1, 1 plus 3 is 4. Absolute value of 4 is 4. Times 5 is 20. Divided by 2 is 10. Plus 7 is 17. They both work. If you ever see a problem like this, you're done. Absolute value of x cannot be negative 3 because the absolute value of a number is always positive. But don't be too quick to jump to that conclusion. It might seem like a no solution because absolute value cannot be negative, but remember, we have to deal with that 5 first. When we deal with the 5, then we find out, well, the absolute value of x is 2, which is positive, which is possible. And then we would have to continue to solve. For a solution of, which could be written as, that's the plus minus sign, x equals plus or minus 2. That is two different solutions right there, both positive 2 and negative 2. But mathematicians are lazy, so we always find ways to write things simpler and easier. So when you're faced with a problem like this, where you have an absolute value sign and a negative on the other side of the equal sign, always make sure that the absolute value part of the equation is isolated, all by itself, before you decide if there's no solution or if there is a solution. If it's all by itself and the other side is positive, there'll be a solution. If it's all by itself and the other side is negative, then there'll be no solution.